Today I'll be talking about automating time series analysis for the Paleogeosciences and in particular the field of paleoclimatology. So why do we study paleoclimatology? To be able to answer questions such as, has the climate changed in the past? How much? How often? How fast? And why? Specifically, we use time series analysis so that we can identify periodicities which might be associated with a known phenomena, to investigate the temporal continuum, to understand how energy within the Earth system is redistributed across various timescales, to detect regime shifts, and to identify coherent spatiotemporal variability between multiple time series. Analyzing paleoclimate time series is actually very challenging, both on the technical side and especially on the social side. On the technical side, we need to keep in mind that the data is often not evenly spaced in time. The data is noisy. The data is highly uncertain in both time and the environmental parameter, and the handling of long-term trends in the data is important to interpret the records. On the social side, often the researcher who understands the data the best may not be well versed in statistical methods. What we wanted to do is create an automated system for time series analysis aimed at those researchers who have a very good understanding of the data, but not necessarily how to express the statistical methods. So what we did in AutoTS is first capture expert-grade strategies as an abstract workflow template. So this is an example for spectral analysis with pre-processing, including detrending, removal of outliers, and hypothesizing over missing values. The second step is to actually create a catalog of methods that can be used to instantiate those abstract workflow steps. So in the case of spectral analysis, we have methods such as MTM or Lomskargol to do so. The next step is to be able to capture property of the time series after each step to express constraints on downstream components. So one of the one that we've been studying is whether or not the time series is evenly spaced, and that matters for the downstream component, which spectral analysis method that we choose, since the MTM method requires evenly spaced data, so we need that step, whereas the WWZ method, which is based on the weighted wavelet Z transform, does not require evenly spaced data. And what we can do is use a reasoning algorithm to propagate those constraints through a workflow and automatically generate the executable workflow instance from that template, such that if MTM method is selected, then there is a hypothesizing over missing value step, in this case linear interpolation. Whereas if WWZ is selected, then this step can be skipped.